Hi, my name is Joe Hackman, and I'm going to be talking to you about architectural acoustics in small multipurpose rooms. Before we dive in, we must ask ourselves, what is architectural acoustics? Well, architectural acoustics is a study of the properties and qualities in buildings and spaces that determine how sound is transmitted and propagated through the air. Some important acoustics terminology and descriptors can define how a space sounds. So, a space that has significant reflective material or is reverberant is live, and contrarily, a space that has significant absorptive material and low reverberation is dead. So, as an example, a cathedral could be described as having a live sound due to its echoic properties, since it has lots of reflective materials in it, like stone, glass, concrete, some wood, marble, things like that. The location of this study is in West Village Room 175 at Georgia Tech to understand the sonic utility of small multipurpose spaces. This particular room hosts a multitude of functions ranging among choral performances, ensemble rehearsals, and lectures and presentations. Each of these uses has different acoustic requirements. The goal of the study is to determine if the current design of the space satisfies each use case, and if not, what can be done to improve the space. West Village 175 currently possesses multiple acoustic features, including reflective angled panels, variable curtains along the front side walls, and an absorptive demountable partition along the back wall. The table below shows the different states of each element, which can result in a total possibility of 8 different configurations. The most absorptive configuration has the curtains closed, panels open, and partition closed. Conversely, the most reflective configuration has the curtains open, panels closed, and partition open. Ultimately, we're most concerned about the curtains and the demountable partitions, since those actually contribute to the most absorption. In order to measure the room in its current state, we must conduct some measurements. These measurements are considered standard practice and generally provide an appropriate representation of a space's acoustic properties. The reverberation time, RT60, is a measure of the reverberation time by a reduction of 60 decibels. This is related to T30, which is the same concept but scaled by a factor of 2. T30 is used generally when background noise is relatively high, such as in this case. Frequency response is determined by a fast Fourier transform. The frequency response characterizes a space based on a stimuli, such as pink noise. Different materials absorb sound at different frequencies, which affect the properties of the total reflected sound. The results from these measurements show that the room has a total range of about 0.4 seconds in difference of reverberation time, and the frequency response remains relatively unchanged between the most absorptive and most reflective conditions. Our goal for speech for this room is to get as close to or under 1 second of reverberation time. Clearly, 1.32 seconds is not under 1 second, so we can add some additional absorption to the room. Since West Village 175 is a relatively small space, the reverberation time based on materials of the room can be calculated within a reasonable confidence by applying the Norris-Eyring equation. This calculates reverberation time based on the volume of the room, surface area, and the absorption coefficients of the materials which compose the room. This equation is applied to the existing room conditions as well as some additional cases in which absorptive material is added. Applying this equation resulted in the measurements shown below, where you can see there's a wide range of reverberation time, and configuration 4, configuration 3 with partial carpet, is as close to 1 second as we can probably get, which is ideal for our condition because we still want enough reverberation because the room is large enough, but we wanted speech intelligibility to be satisfactory for the space. The differences in RT60 between the most reflective and most absorptive configurations is 0.4 seconds for the measured states and 1.3 seconds for the predicted states. This demonstrates that with the addition of rollout carpet, the room can suit a wide range of reverberation times. About 750 square feet of carpet was acquired based on the parameters of configuration 4 and placed into West Village 175. A recording session was held to demonstrate the differences in reverberation time. Musicians absorbed a drastic reduction in reverb when curtains, partition, and carpet were all engaged. For speech intelligibility, An RT60 of 1 second is an industry goal, particularly in classrooms where speech occurs. Both through calculations and the above observations, this is now achieved with carpet. The frequency reveals that the frequency response of the room remains relatively unchanged based on the configuration. An acoustics handbook will educate users about acoustics and the configuration they should use to meet their needs for the space. And ultimately, this achieves the goal of the project and concludes the case study. Thank you very much.